All right. So it's just going to be you and me today. So I think let's just take a look at the homework and make sure we talk at least a little bit about each section. We don't have to spend too much time on it, but I did make notes and examples, instructions, things like that, that will be on the Brightspace page, and I do recommend looking them up and looking at them while you are working. It's got written in all of the various tips for working the fraction questions, reminders on how to do the algebra stuff, and probably most importantly, the part that I think is the hardest on this entire homework set is the logarithms section. So there's 4 of those log problems present, and this little table here will be important for being able to do those. Excuse me. So I want to go through at least a couple examples with you from each section today, and I'll let you pick a few of them if one of them looks especially tricky. You want us to handle that one together. But do refer to these. I'll keep this up and tab back around if we need them for any of the examples that we're working together. So, we've already talked a bit about, just a reminder, or a refresher on the order of operations, MS. Do you want to talk about that any further, or do you want to work any of those ones specifically before we move on to some of the other sections? Okay, I didn't think so. That's entirely just review. How do you feel about the fraction questions? If you've looked at those yet, I know they come at the end. Yes, pretty much. You want to add them if they're if you're adding them, common denominator. You can just multiply a number by a fraction though. So for example, say 26. You can just multiply 5 by 3 there and make it 15 over 7. Because if you think about it, 5 is 5 over 1. So you multiply the 2 numerators and the 2 denominators. The denominator would just be 1 for the 5, and so it would just be 15 over 7. I bring it up just because of that, tripped up a few other people in the other lecture. Any issues you foresee with the fraction questions?
When you divide, you got multiple numbers, right?
Yes, that is entirely legal. Not exactly. It's a good question. It's a very good question. 31. Because the 1/3 plus 1/9 is itself a function, and let's just solve together what the difference between 1 over 3 plus 1 over 9 would be versus 3 plus 9. This would just be 12 if it was able to invert to that. But 1 over 3 plus 1 over 9 would be, we have to make a common denominator, so let's do 3 over 9 plus 1 over 9. So these would add up to 4 over 9, which, if you invert that, is not the same as 12. So I would advise adding these together first, which means that from start to finish, 3 over 1 over 3 plus 1 over 9. We already figured out what these are, so I say we go ahead and put this in instead of all of these. 3 equals 4 over 9. Now, we can multiply by the inverse of this. How's that look? Okay. There's 30 does not have that same trick in it. I think 30 is a little more straightforward. No. Let's start 30 together because that's giving me a little bit of hesitation as well. So for 30, we've got 1/5 divided by 5 plus 4 over 1/4. I would recommend trying to eliminate these fractions entirely. Because fractions within fractions is just a headache. So, what I would try to do is take both of these individual ones and do multiplying by the inverse, which would give us 1/5 times 1/5, actually. Because this is dividing by 5, so the inverse would be multiplying by 1/5. Meanwhile, over here, we have 4. We have 4 divided by 1/4, so that would be 4 times 4. So this becomes 1/4. Oh, sorry, 1/25. That's even smaller than a quarter. And that becomes 16. And now you're set to try to add these normally. And although, if you were trying to find, why am I doing that? If you were trying to get to one numerical answer, it would probably just be 16 point something.
What about 27? Can we just do the same thing when you get like the A's and B's?
Right. So 20, yeah, you want to, 27 you want a common denominator. The only difference here is you just don't have, you're dealing with letters instead of numbers. So to add anything, the denominators have to be common, and what's the only common denominator we can make here? AB. So multiply both of these by a B, or B over AB. Multiply these both by A, 3A over AB. And this is the only question in that section whose answer is going to have letters in it. It's okay if the combined answer is okay to leave at 4B plus 3A over AB. The PEMDAS section and the fraction section are similar in that for most of them, your goal is to find a number. So you're just taking the one thing, collapsing it in to get a single number. The other 5 sections are all algebra, involving at least one letter each. And the goal there, with most algebra, is you have a formula, you want to solve for one letter of that formula, and you need to rearrange the whole thing to get x equals blank. So this is where one has to engage in moving things from one side to the other, by performing the inverse operator, to try to break it down, and just get the one thing you want. And I would like to do at least one from each section of today.
I got set on 6 on the Saturday on solving things.
Number 6 is a doozy, so yeah, let's talk about that. Now, that should be minus. Now, what are your thoughts on wanting to keep everything when I do these, I try compressing the numbers down. This whole term up here, I can find one number for. I can combine all of these into a single number. The 5/3/2, I can combine into a single number. And usually that's how I do the work. Some people prefer to keep everything separate until the very end. Do you have a preference? Okay. Are you okay if we combine terms so that there's fewer things that have to move around? Okay. So, end goal is the x. The things that we can already go ahead and compress together are this numerator and this complex fraction. This numerator, 2 to the 3rd power is going to be 8, minus 9 minus 8 over 3 plus x, minus, to help work this, I like turning it into 5/1 times 3/2 equals 18. So we can compress this. 8 minus 9 minus 8 is just going to be -9 over 3 plus x minus 15/2. Equals 18. And that's a few fewer things that you can manipulate.
So far on that, is you add the 15 over 2 over to 18.
Very good. So -9 over 3 plus x equals 18 minus 15/2. Sorry?
When you plus 15 over 2.
Oh, no, you are absolutely right. I made a mistake there. So 18 plus 15/2. Then what?
Then multiply it by the bottom inside the -9.
Very good. So -9 equals 18 plus 15/2. Why did I write that? And since you're multiplying this entire side by 3 plus x, you need to insert some parentheses to make that clear in your math.
Yeah, that's what I got stuck trying to figure out how to get that
Right, so this whole thing is being multiplied by this whole thing.
So you just fool.
We could FOIL. We absolutely could. There's a completely valid way to get to the answer by foiling these two things together and working from there. Now, this is just my preference, but if I have an option between foiling something in or sending it to the other side and not having to unpack it, I tend to prefer sending it over. And we could just divide both sides by 18 plus 15 halves. You okay with that? Okay. That would give us -9 over 18 plus 15 halves equals 3 plus x. It's still a very complex fraction, but we didn't foil and invent new terms for ourselves. And
Just subtract.
yep, we've almost got the x by itself at the very least. -9 over 18 plus 15 halves. That whole thing is its own unique term. All of that minus 3 equals x. So that is at least x by itself. This whole thing will equal one number. Would you like us to find that one number together?
Just gotta put it in the calculator.
That would work, yes, as long as you make sure you input it correctly.
I am going to write up here how I would put that into the calculator. We have open parentheses, -9 divided by another open parentheses, 18 plus open parentheses, 15 over 2, close parentheses, close parentheses, close parentheses, minus 3. What numbers did I give you? Sorry.
-57 over 17.
Okay, I'm just gonna double check that myself, because I don't have my answer word in front of me. Yep, -57 over 17. Very good. That looks to me like the most complicated one in this section. If there's another one you want to talk about, or if we... I'd like to move on to some of the other sections, because I definitely want to at least work one or two of these longer ones with you before the weekend. The next section, the one without numbers, works exactly the same way as the previous section. It's just nothing will compress because it's all letters. And I think the hardest one might be 12, just because it has the most terms in it. It's not even that the X is hard to get to, there's just a lot of things to write down. So, unless there's something else in there that you'd rather look at, I'd kind of like to put that one up on the board so we can follow it and keep everything square together. Do 12? Okay. I'm going to clear off this board because it's going to be a little bit of space. Now, most of the time in physics classes, you're not going to have to deal with formulas that are only letters all the time, but it does happen, especially if you're taking a Dr. Rodecore class. So it is a good skill to have to be able to keep all the numbers and letters straight. And I know this formula, I have used this formula myself, so I know, just from my own experience, all of these weird looking small p's are the same, meaning that if one is divided by the other, they'll cancel. Meanwhile, though, the h's with the two different subscripts, you have an h1 on the left and an h2 on the right, represent different numbers and won't cancel. Same with the P1 versus the P2. But it's the same G on both sides. Those would end up canceling too if that ended up happening. And there's a lot of terms, but the X itself only has these two things stuck to it. So I think the first and biggest step is just getting these to the other side. Because if we're doing sort of the order of operations backwards, we call it SATMEP, because you want to get rid of the things being added, subtracted to the term, then you deal with the things being multiplied, divided into the term, then you deal with the exponent. So these two things are being added to it, they just need to go over to the other side.
So you just subtract those two, maybe divide by 1/2 p, and then let everything under square root of x on.
You absolutely can. So let's get 1/2 px squared equals p2 plus pgh2 plus 1/2 pb squared minus p1 minus VGH1. Then, as you suggested, we can just divide both sides by 1/2 P. Again, it's not that each individual operation is tricky with this one, it's just there's a lot of letters. And then take the square root of both sides, and you have that monstrosity. Everything in that section should work pretty similarly. And the answers there are going to look like big messes. That's fine, you can leave them as is. There's a couple things I might think to do to be able to compress this, but that really wouldn't make it that much simpler anyway. So, in terms of this section, I'm absolutely fine if the answers look like this. Powers section, every single thing there is going to involve some type of square root to be able to get your answer, except they're not all square roots. Some of them are like 5th roots and 8th roots. Do you know how to get to the not square root function I've got there? Okay, good, just checking. At least, 2 of those are going to have an answer with letters in it, so you don't need to get a number there. Oh, interesting. So between 9 through 20, is there anything especially concerning you? We're absolutely going to keep working on these in class. I'd rather do like more specific work when the classmate can also benefit from it. But for now, I also want to make